Question 2 is the exact same thing as question 1, except that the format is a little bit different. It wants to know if a precipitate of silver chromate is going to form. All right, so let's check it out. We start all these problems out in KSP the exact same way. So you take your substance and you break it into its pieces, like so. And then you set up your Ksp equation. So we end up with this guy here, that the silver chromate is going to go to 2 silver plus 1s and a chromate, and the Ksp then is going to be silver squared times the chromate. I got an I, I got a C, and I got an E, and I don't care about this because it's a solid. And then we go and we put our numbers in. This is 2 times 10 to the negative 4th, and this is 3 times 10 to the negative 5th. Now, careful. Some people want to get too smart by half here, and they're going to say to themselves, wait, there's a 2 here, so shouldn't I double this number? In this case, no, you shouldn't. Why? Because they just told you what the number was. They just told you that it was 3 times 10 to the negative 5th. If they had said that it was some silver substance that was dissolving into that and it had 2 silvers, then you would have to double it. But really that aspect comes around in the change part of things. All right, that's where that 2 is going to come into play, as well as being up here. So if they're telling you what the concentration of the silver ion is, just go with it. So again, if they had said up here that you had, I don't know, 0.2 molar silver sulfate, right? And then you're interested in the silver part of that, well then yeah, in that particular case, then you would have to look at it and say, all right, well it's really going to be 0.4 molar in the silver because there's 2 silvers that are there, and it would be 0.2 molar in the sulfate over here, assuming that we had perfect dissolving, 100% dissolving here. But that's not what they're telling you in this problem. They're just flat out telling you that the silver is that concentration. So you don't have to double it. So we don't know if this is at equilibrium or not, so what are we going to do? We're going to plug it in. So this is going to be 3 times 10 to the negative 5th squared times 2 times 10 to the negative 4th. So my Q value then is 3 times 10 to the negative 5th times 3 times 10 to the negative 5th times 2 times 10 to the negative 4th is going to get me a Q value of 1.8 times 10 to the negative 13th. And they told us that the K value up here is 1 times 10 to the negative 12th. So Q is less than K. So if Q is less than K, then the reaction goes over to the right-hand side, which is the dissolved side. And if it's on the dissolved side, it's not on the precipitate side. So this is no precipitate forms. Q is less than K, so no precipitate forms. So again, that is an answer. This one could be a possible answer. These two don't make any sense. It can't be yes if Q is less than K, and it can't be no if Q is greater than K. So with this format, you've got a 50-50 shot at it if you know a little bit about what the situation is going on, because you should know that no because Q is less than K is a possible, and yes because Q is greater than K is possible.